Hello students, welcome to Dr. Shourabh sir classes. So as you know that we have already solved the paper 1 of this mathematics optional paper in UPSC of this 2021. So from this video we will be starting this solution of UPSC maths optional paper, and we will consider this, we will do the paper 2 of this 2021. Okay. So this is the first question, as you know that this 1a we have. So let's start this question. So it is given that let m1, m2, mk be positive integers and d is greater than 0. The greatest common divisor of this m1, m2, mk, show that there exist integers x1, x2, xk such that d is equal to x1 m1 plus of x2 m2 plus of up to xk mk. So that is the thing we have to do, right? So what is this common greatest common divisor? So just for the understanding, I'm just going through that. So the thing is that a integer, suppose the integer is d, is greater than 0, which is greater than 0 is called a GCD, that is the greatest common divisor of two integers a and b. So these two integers are non-zero, it should be non-zero. So if this d by a and d by b, and if c by a and c by b, then we can write it c by d. Okay, so we can write this GCD, that is d is equal to this GCD of AB. Okay, so this is the GCD of AB, or simply we can write as d is equal to a comma b, right? So let us take S, so equal to this AU plus BV, where this EU and V are integers. Okay, and AU plus BV is greater than 0, right? So from here, if A is greater than 0, then we have this A equal to A into 1 plus B into 0, so that is greater than 0. So A is greater than 0. Now if A is less than 0, then we have minus A into minus 1 plus B into 0 less than 0. So we can say that minus A belongs to this. Okay, so this is minus A belong to this S, right? Yes. So here also, so here it is A greater than 0, so here we can imply that A is an element of S, as we have defined S over here as AU plus BV. Okay, so now similarly, if we do this on the other hand, that for B greater than 0, then B belongs to S, and it be less than 0, then minus B also belongs to this S. Okay, so from here is we can say that S is not null. Okay, and S contains positive integers, right? And S contains positive integers, right? So by well ordering principle, S has at least an element. So the principle that we are talking about, that is the well ordering principle. S has an at least element. This at least that element, say S has a element, that is D. Let us take this element as D. So now we have this D will belong to this S, right? So D is belongs to S, such that this D is equal to AX plus BY for some integers X and Y, and let us take this equation 1. Okay, so XY is some integers, and from here also D is greater than 0. So to prove that D is the GCD of A comma B, so we have to take this, let us take this A equal to DQ plus R, right? So where this R ranges is between 0 and T. So R is less than equal to 0, less than equal to D, less than D, right? So then if R is not equal to 0, then we have this R is equal to A minus DQ, or we can write it as this, put the value of D from 1, that is AX plus BYQ, right? So from 1 we get this. So what it will be? It will be A 1 minus XQ plus B minus YQ. So this is greater than Z. This is greater than 0, right? A of 1 minus XQ and B of minus YQ. So this should be greater than 0. So where this 1 minus XQ and this YQ, right? So minus of YQ, sorry, these are integers. So from here we can get this R is greater than 0, and also R belongs to this S. Now if R is less than D and R belong to S, as we know, which is a contradiction to the fact that D is the least element of S, right? So the contradiction is the, as we have mentioned, that D is the least element of S. So from here this R is equal to 0. Okay, we'll consider this R is equal to 0. Now what will be the value of this A? So simply from here, this is the equation. So A is equal to DQ, simple DQ. So from here you can write, so A by D is equal to Q, okay, or you can say it is as D by A, okay. Similarly you can write this D by B. So this D by, simply, so if this, now for the C, suppose let us take that C by A comma C by B, C by A by C by B, this is equal to this, it can be taken as C by AX plus BY, C of AX plus BY, so which implies it is C of D, right? So from here you can just observe it that DA, DB, and also if this CA and CB, then we have this, then clearly from we have this C by D, C of D, right? So GCD, then D is the GCD of AB. By definition we got it, right? So if possible, D is also GCD of AB. So then we can write it as this, if possible, then D prime is also the GCD of A comma B, right? So from here we can write we have to, so what it will be? It will be d prime by a, d prime by b. This is will be equal to d by d prime. This is equation, so the last equation that I gave. Okay, so that the equation number 2. So this will be equation number 3. Similarly, we can write for c, that is d by c, or you can say similarly this d by a, d by b, which implies is d by d prime. Okay, so this is equation number 4, right? So from 3 and 4, what we observe, we got that d is equal to d prime. So this d prime is also, okay, so this d prime is also a GCD of a and b. So this can be extended for more than 2 integers. So for d, so now if we take this, if d is equal to GCD of m1, m1, m2 up to mk, this is the GCD, there exist integers that is the x1, x2 up to xk, such that this d is equal to it will be m1 x1 plus m2 x2 up to mk xk. So that we have to prove. So here it is the question, you can see that show that there exist that integers x1, x2, xk up to xk is equal to d1, d is equal to this. So we have proved this. So how this happens? So since this d is equal to d prime, okay, so it can be extended for more than 2 integers. Okay, right? So now if then GCD, d is equal to this GCD of this m1, m2 up to this, so there exists this integer for which we can write d is equal to m1 x1, m2 x2 plus up to mk xk. So that is the part for this equation number, this question number 1a. So in the next video we will solve the other parts of question a. So see you in the next video.